Let's do another demo we'll call our CalcEngine demo. And what we'll do in this demo is we're going to create a simple application that can go through various just mathematical calculations. As we're starting it in this module, but we'll be using it throughout the course, enhancing it with the various things we learn. We'll start out by creating a brand new project. So I'm going to use IntelliJ for mine, but you can use whatever you prefer. We'll create a new project. Remember that, as I mentioned earlier, that just because of the screen resolution we're recording, you can't see the very bottom of this wizard screen. So you scroll up here, notice there's a next button down there at the bottom. I'm just going to go ahead and create a Java project by clicking next. I'm going to go ahead and create a command line project. Again, down there at the bottom, there's a next button, so I'll go ahead and click that. So I'm going to call this project CalcEngine. And then for my package name, I'm going to be com.pluralsight. And I'll call it .calcengine. So I've got my project name and my package name. Now I'm going to click the Finish button down there at the bottom. So now we have our application created. I'm going to go in here and just get rid of this comment line. Get that out of the way. Throughout this project and throughout this course, as we build in this project, we're going to, again, just do some mathematical operations and have the program kind of just do kind of smarter and smarter things for us. But we're going to initially start out very simple, just doing very, two-member calculations, adding two numbers together, multiplying two numbers together, that sort of thing. So what we're going to do is declare a couple of variables here at the top, first of all. So I'm going to declare two variables that are double, val1 and val2. I've got those two variables. I'm just going to have another double for result. So now I have the ability to have two values to operate on and store the result. And what we'll do is that we'll use a concept we call like opcodes. We're just going to use a one-letter code to indicate the mathematical operation that we want to execute, like A for add, S for subtract, that sort of thing. I'm going to create a char variable called opcode. Right, so that sets up my basic ability to set the values of what I want to do. And so I'm going to go through now and just set up if statements to perform those operations. Right? So the first one would be add. So that's going to be the opcode A. So I'm going to say if, and then opcode equals A. Right, so if the opcode is A, what I want to do in that case is add the two numbers together and assign it the result. Right, so it's that simple. So I've got the A in place now for add, and now I want to do an S for subtract, so I'm just going to do an else if. In this case, opcode equals S. And of course, in that case, I'm just going to subtract value 2 from value 1. And we'll do the same thing for D for divide and M for multiply. And finally, what we want to do is just print out the value of result. Right now, you'll notice here that throughout the program, the IDE is kind of underlining all my variables, right, showing me that there must be something wrong. And what it is that we're trying to use all these variables without having initialized them, right? So what we need to do is go ahead and initialize them. So let's go ahead and set val1 to 100 and val2 to 50. So we've got those initialized. And let's set our first opcode here. Let's just make that A for add. So now we've got all the variables we're using initialized, right? Now we're going to assign result, but it's possible that maybe we'd set the opcode wrong, right? Instead of it being a proper value like A, S, D, or M, maybe we actually put something like X or whatever. So what we'll do here is that at the end of our else if, we'll add an else. And just if it's not any of the values we expect, we're just going to go ahead and set the result to 0. All right, so now we have a very simple program in place, right? That we can actually just set an opcode, set two values, and get the result. Right, so right now I'm set to add 100 plus 50. So let's go ahead and run it. And we display 150, right? So it did the math correctly. Of course, all I have to do now is change this from an A to a D, right? And now it'll divide instead. So if I run it, I get 2, because 100 divided by 50 is 2. All right, so we're off to a good start here. Now we can make things a little better here. I'm going to get this bottom window out of the way. Now, when we have this bad opcode, just showing a result of 0 could be confusing, right? So what we probably want to do is maybe go ahead and put an error message here, right? So let's go ahead and print out an error message that says error invalid opcode. Right, so now if we put in a bad value, it would actually just display a message and show something useful, right? So now I currently have a good value here, though. The opcode is D, so that's still fine. Let's go ahead and run it and make sure everything's okay. And you'll notice that when I ran it now, right, I didn't get the proper answer 2.0, I got 0, right? And that's because I need to make this a block else, right? Or a block statement with this else, right? Because remember, the else only ties to the one line here. So by actually adding this print statement here, I'm forcing it to always set result to 0 no matter what it's done before that. So I'm going to make this a block statement. And now, of course, it'll do the right thing, because it only sets result to 0 if we're inside the else block. So of course now if I run it, I get my 2.0 displayed again. Right, now, one other thing, right? We're still exposed on our divide to a divide by 0, right? So a good programming practice, of course, is to always check to see if the bottom value of the divisor is 0, right? So what I'm going to do here is say that if val2 is not equal to 0, then in that case, I'll do the division. Right? Otherwise, I want to set the result equal to 0. Right, so now if I run it, leaving val2 as 50, it displays 2.0, but if I change val2 to be a 0 and run it, now I get the 0 out, right? So it's doing the right thing. Now, one thing to note here is that an if statement like this, where you simply do a condition and then set a result to one thing or another, right? That's a great time to use that conditional assignment idea. So what I can do here is instead of that if else like that, I can simply say result equals val2 not equal to 0. And if it's not equal to 0, then go ahead and divide val1 by val2. Otherwise, return 0. Right, so that one line replaces all of this. So I'm going to go ahead and comment that out. So now if I run it, it still runs correctly. Right, so 0 because val2 is 0. If I change val2 back to 50, run it again. Right, it's now 2.0. Now, one thing to note here is that it appears that we have multiple lines under this else if for opcode equals D, but remember that those last 4 lines are commented out, right? So it's still treated as if there's only one line under the else if, right? So we didn't need to make that a block statement. But in a situation like this where I've got code hanging around that just kind of can be confusing because it just may seem odd that I've got all these statements there and they all seem to apply to the else if, it's often useful to go ahead and use a block statement just to make your code more readable. Right, so what I'm going to do is just put this in a block. Even though it's not necessary for the program to run correctly, it makes the program much more readable.